Okay. Here we go. So, we're starting into the metric system. We are going to go through this quickly. You have had this many times, sometimes in math, sometimes in science, sometimes both. But we are most definitely going to try to go through this fairly quickly. Let me show you this before I forget. In Google Classroom, beneath today's post, once I post it, there's a new GIM kit for metric vocab, the metric system, metric vocab, metric practice, metric vocab, combined metric practice for all of our Quizlets, Blookits, GIM kits. There's no Kahoots, but they are all there. And the unit materials, yes, metric unit materials. So if you would need the notes or the vocab, it's all here for you. Okay, so at the end of a unit, I post the new stuff. It's also always in classwork. Go to unit materials and you will see the metric here. If you want the unit links, they are there. Okay, so if you get bored in homeroom or study hall and you want something to do, just start practicing, go on those links. Okay, practice vocab, or you can see how you're doing just with the metric stuff. Right? You might surprise yourself and already know quite a bit. Everybody will be kind of a little bit different on how much they are still remembering from years previous. Okay? Ahora necesitamos empezar las notas.
Okay.
The notes. Oh, wait, something. The only thing I know is something about the notes.
Escribe tu nombre en tu papel.
Write something.
Necesitamos
Write your name
empezar.
on your note and pencil.
¿Cuál es un problema cuando hablar en español no puedes entenderme?
Okay,
There's
there's a
no
problem.
Es un muy problema grande.
Very
That
good
problem, yeah.
You will have seizures if you talk in that language.
Do we have to take
No puedes entenderme cuando hablar en español, ¿no?
He
No
doesn't
puedes entenderme.
know, he doesn't know
I'm
Espanol.
doing
not in.
He doesn't know Espanol.
I don't know Espanol either.
Es muy difícil para entenderme cuando hablar en lengua
Whenever she says Florida
in
Episode,
English.
she wants us to get these
I
papers
think
out.
I do it.
This is Florida Episode.
Yeah, we have a para epizar and
She says that, but she also says, hola clase, every day.
hola clase, ¿cómo estás?
Okay.
Bien, ¿y tú?
So, bring it back. Hey, I'm not just speaking Spanish at you to give you seizures. I was curious because you guys, a lot of you are in Spanish and a lot of you are always talking about Spanish in here. So I was kind of curious what your reaction would be. You're not really expecting me to start the lesson in Spanish, probably, right? So I used to be fluent in Spanish. Not all that was perfectly grammatically correct. Don't let Mrs. Senora House grade me. But what I was saying is, we need to begin. Put your name on your paper. Do you have a problem when I speak in Spanish? You can't understand me unless I'm speaking English? You know, so I was saying a variety of those things. You're all looking at me like, no, I did not get all of that. Here's the thing. The reason I'm doing this, besides seizures, is the idea that the metric system is like a foreign language. It's like kind of familiar. Yeah, I've heard that word. That seems like something maybe from some time ago, but it's not something you're comfortable with, right? Let's be honest. See, right? So the point with what I want you to get from this year, and from our conversations yesterday, some of you are like, yeah, no, I don't know, kind of, it confuses me. I want you just to be able to have a general understanding of what compares to what. We know things in our everyday life. You know how wide your pinky is. You know how thick a dime is. You know how high a doorknob is. Those are some of the things that we're going to compare to metric things. If you think of the everyday things that you are familiar with, you can compare those and have an understanding. Oh, that's how thick a millimeter is. That's how high a meter stick is. And so you'll be able to kind of make those comparisons. So that's what I would like you to take away from this. Kind of a more practical application or use of the metric system, not just like, okay, try to memorize this and do this. Like, actually, what does it really relate to? Things that you already know, how does that kind of compare to things in the metric system? All right, and so that's what we're gonna focus on. All right, so definitely Spanish is a foreign language, but hopefully by the end of this, the metric system will not be a foreign language. Okay, and don't tell Anna I start talking in Spanish, and tell her she needs to watch the video notes, okay? All right, so some of you were looking at this. It says, so today we're gonna convert to the metric system. And he says, but we're inch worms. And she says, wrong, Ian, we're 2.5 centimeter worms. And he's like, go back to France. So an inch is equivalent to 2.5 centimeters. And so if you're converting to the metric system, 1 inch equals 2.5 centimeters. So she's trying to explain, no, we're no longer called inch worms. If we're changing to the metric, we have to change our name, right? When I was, it was one of my first years on the junior high school side, and I had Mrs. Feaster in my room. She was a special ed teacher, and when we were going over the metric system, she said when she was in 3rd grade, she remembers that they had decided, the government made this announcement, like, hey, we're gonna slowly start transitioning to the metric system. The rest of the world uses the metric system. We're the oddballs. And so they made this big push, and so she said all of 3rd grade, she goes, all I remember doing is learning the metric system. And so, you know how in school we learn inch, feet, mile, right, gallons, liters, gallons, ounces. And so she's like, we just learned the metric for all of that. It never happened. We've never converted and switched over from the US customary to the metric system. So I just thought that was kind of interesting. She's like, I don't know what happened. She's like, but it went away. But if you think about it, think of all the things that are in our measurements. You go to the gas pump, it's in gallons. You are driving on the freeway and it says 200 miles to get to Louisville. Think of all those signs, all the materials that would have to get changed, new signs, new, pumps, new all kinds of things that would have to change if we switched from our measurement to the metric system. So think how much money that would cost. So maybe money is one of the reasons why we have kind of stuck with our US customary. Yes?
What do you mean pumps?
Like at the gas pumps, gas pumps. You go to get gas and you pump it in gallons. Well, you'd have to start pumping in liters if we switch to the metric, right? So all of those things that are measured in gallons now would have to switch over to liters. So whether you're talking gas, diesel, kerosene, even like propane is measured in pounds, right? So all of those things we'd have to get new equipment that was measuring in metric units. So I think part of the reason is that we are kind of, I don't know, maybe lazy. Like it would be really hard. Like it wouldn't be so hard for you guys, but the older you get, the harder it is to adapt and change to things. And so it'd be really difficult, even like for, my generation, it would be like, ugh, like that's really hard. We're used to doing everything in our unit of measurement. And so there'd be that transition where it would take a little while. But I think a lot of it probably comes down to the money aspect. All of those things that would have to change. And that costs a lot of money. Think of the billions of road signs. I mean, couldn't even imagine. And then you pay all the workers. You pay, just the time it would take. So I think part of it, that's why that we are still with our U.S. customary, even though we are pretty much the only country that use it. Actually, we are the only country that use the U.S. customary. All right, so this is slide number 2. You'll notice that these slides are a little bit different. This is the only unit where it's like the printed PowerPoint version. There's some more pictures and diagrams, more than there's actually words in this unit. So that's why I kind of leave it like this, so it kind of matches better what we're doing here. But we'll go back to our normal notes like we had last time from here on out after this unit. So I know that you have small blanks that you're going to be filling in. I try to keep the words small and pretty minimal because I know that it's kind of tight on those slides. All right, so the slides do go like 1, 2, drop down 3, 4, and the slides are numbered in the bottom, so you can see that to help follow along on your paper. But in the early days, scientists used their own local system of units. And that's fine, like when you had small tribes and villages and there wasn't a whole lot of intermingling, and there wasn't a lot of trading, and there wasn't a lot of travel, right? But as the world started to change and people started interacting more, there was a lot of confusion, because you had people dealing with one thing in one village and like one type of unit or measurement in another, and then when they start talking, it's like comparing apples and oranges. They didn't understand each other. They couldn't follow what this amount was for them and what this amount was for the other tribe or the other group or the other village, okay? And so a lot of time was kind of wasted trying to explain and be like, this is what I mean, this is how much, right? And so trying to explain that was just kind of, silly. It's like, okay, we have to find a way to make ourselves clear to everybody so we all understand the same thing. So it's like, I'm not speaking Spanish and you're speaking English, right? There's a little understanding, but there's a lot of confusion too. And so the metric system is a universal standardized form of measurement that all scientists are going to use. So most countries use a metric system, but all scientists. That includes the medical field. If you've ever, which I'm sure all of you have gone to the doctor at some point and you've gotten weighed, they do that in kilograms, right? You get on the scale and they find your mass in kilograms. And so you're probably like, well, okay, so how much do I really weigh, right? So you have to times it by 2.2. That's the conversion to go from kilograms to pounds. So if you weigh 50 kilograms, you're right, a little over 100 pounds, okay? And so all of medicine is dosed with the metric system. So it's milliliters, not ounces, milligrams. If you're talking a solid pill, like 200 gram or milligram ibuprofen, right? If you see a bottle of ibuprofen, it says mg per milligram. Yes?
Do you use metric system to measure other things like caliber of bullets?
Absolutely. And we're going to actually talk about some of those things. If you work on any kind of like machinery, there's the US customary, like the 9/16 wrench and the 1/2 inch wrench and the 3/4 inch, but then you also have the metric version of those things too, right? So you have like a 9 millimeter wrench, you have a 13 millimeter socket, right? So you have the English or the US customary, and then you also, because it seems like whenever I'm working on something, I'm thinking it's the metric and it's not, and then when I think it's the US customary, it's not, and then you have to have both sets of everything. And we're the ones that cause that. We're the ones that have the US customary system. Everybody else has the metric. So if we would just use the metric system, we wouldn't have to have kind of two of everything with our tools. So the official name of the metric system is called Le Système International des Unités. SI. That's why it's called the System International. We call it the International System. But French and Spanish, like, that you say, we say a red car, right? We say the adjective and then the noun. Red is the adjective, car is the noun. French and the Romance languages, they actually do the reverse. They say coho, or coche rojo. Car red. So you're picturing a car and then you paint it red. That's backwards. So this is why this is kind of backwards. We call this the international system. They call it the System International. So it seems kind of flipped for us. But again, our language is different than theirs. So if you see the SI units, they're talking metric. Okay. So anytime you see SI, it's the metric system. So, the United States is one of only several countries in the whole world that do not use the metric system. Our system is not friendly. It is not easy, and there's really kind of no rhyme or reason to it. So, it'd make more sense if we use the easier system. Now, the metric system seems harder to us because it's not what we're familiar with. It's like hearing Spanish. We're used to hearing English. Right? But if we would get used to it, it is much easier. Our system is called the US customary. And so we have to have a conversion equivalencies for
volume, we have to have that for length, we have it for mass. So we have 3 unique systems for our 3 types of measurements, mass, length, and volume. The metric has 1 system, and we get to use that for all 3 of those types of measurement. So you have 2 to 1, 2 to 1, 4 to 1, 4 to 1, 8 to 1, 16 to 1, 12 inches to a foot, 3, 36. Like there's nothing, 12, 3, 36, 17, 60, 52, 80. What? Like who remembers those numbers, right? The metric system is all base 10. 10, 100, 1,000, 10,000, a tenth, 100, 1,000. It's all a matter of tenths. And so that makes it much, much easier. Okay, so here's kind of trying to show the difficulty of the US system. It says, okay, here's the play. Go out 10 meters, then cut left 5 meters. Meters? Like you're playing football. Like it's 5 yards, 10 yards, right? He's like, Jason, this is football. Everything in football is measured in yards. Like, what's wrong with you? Says, look, in order for me to get the ball to you at the right place, at the right time, I'm going to need to do a whole bunch of trajectory and motion calculations in my head. Trust me, it's a lot easier in the metric system. He's like, I'm telling you, I can't play football with metric. It's weird. He says, fine, go out 10.93633 yards, then cut left 5.468066 yards. He's like, well, tell you what, let's just stick with the meters then. Right, so trying to show our system is not easy. It's not simple. It's familiar, so we're comfortable with it, but it's not easy. And so think about it. If you think of like the Olympics or track, 100-meter dash, 200 meters, 400 meters, right? Track is an international type sport. Same with swimming. You have the 50-meter, the 100-meter fly, whatever, right? Football is an American sport, right? Other countries might play it, but it originated here. This is where it starts. Same thing with baseball. It's an American sport, and so we do the measurements in U.S. customary. Yes?
Actually, football originated outside of America, but it got turned into football here. It started from rugby.
Okay, good point. But it is what it is from America, right? So, yeah, our things that we have been in charge of, we've made the measurements or, you know, the game rules based on U.S. customary. If it's more of an international type thing, you'll see it be the metric system, right? And those might be things that you've never really thought of before, like, oh, okay, like you just take it, like you get track and swimming, it's always the metric. Like, it's like, yeah, whatever, okay, 100-meter dash, got it. Okay, so why is this all important? Who really cares? Besides, it's in school and you have to learn it because the state tells you to. Well, this can cause some big problems. If we don't realize that everybody else is using the metric system. So in July of 1983, a Boeing 767 ran out of fuel mid-flight. That's a problem, right? Thank goodness everybody, they were able to land safely. Nobody was injured. But the jet did have to make an emergency landing, obviously. And so thankfully the 69 people were unharmed. But apparently the pilots thought the fuel on board was weighed in kilograms when it was really in pounds. And you would assume that it was kilograms because it's an Air Canada flight. Canada uses the metric system. And so since every 1 kilogram is 2.2 pounds, the plane took off with about half of the fuel that they thought they had. That's a problem, a big problem. And so, you know, we're the ones that are the oddballs. We're the ones that use the U.S. customary system when the rest of the world uses the metric. So because of that, I feel like it's kind of our responsibility to always be the one to be very clear on what we're using. Now, whoever fueled the plane and it was in pounds, like, I don't know, that's odd. Maybe like the plane would, I don't know how that all happened. But, you know, everybody has to kind of double check because everybody involved is responsible. But, you know, as scientists in the global community, we have to make sure that we are the ones that are using the metric and not expecting that the units are going to be in U.S. customary. And that's also why it's so important to have units included. So from now on, numbers alone are not okay. You have to include the unit. If they had, you know, maybe they were reading 700 pounds, when really, if it had had the LBs, they would have realized, oh, that's LBs, it's not kilograms, and they wouldn't have taken off with only half the fuel, right? If they'd had the units by the gauge, then they would have known that. So units are gonna be super important from now on. Let's do this one. So the metric system uses base 10, and it's awesome because we don't have to memorize any kind of conversion factors. We don't have to remember that there's 12 inches to a foot, and that there's 3 feet to a yard, and that there's 1760 yards in a mile and 5,280 feet in a mile, right? And that's just for length. We'd have to have a whole different system for volume and for mass. All we have to know is how the system works, and then we can plug in those different types of measurements that we're using, whether it's mass, whether we're looking for mass, volume, or length. Okay, so the key points to the metric system. We have to know the 6 prefixes, which you should have recognized from your vocab. We have to know we have to know the order, because that helps us know that we're going up by 10 or down by 10s. And then we have to know the 3 base units, and that's what we will pick up on Monday.